The Operation Icebergue team has swapped its glacier camp in Greenland for the research vessel Neptune. 23 scientists, adventurers, and camera crew are setting off on an ambitious 2-week expedition.
I think we just need to think through that plan now and make sure that...
They're heading across these waters in search of a massive Arctic berg. Helen Chersky is a physicist and oceanographer. She's interested in what's happening to the ice itself.
I'm fascinated by the mechanisms, what's going on and why it's happening inside this iceberg and how it lasts so long.
When you look at the photos, you can see the algae actually on the ice.
Naturalist Chris Packham wants to understand the role icebergs play in the environment of the polar seas.
Icebergs carry with them an almost mythical aura. We think we know them, but we don't. They're still very, very much of a mystery.
Joining the iceberg team is a group of renowned ice scientists.
This is a very rare opportunity because you very seldom get a large Arctic berg. When you do see them, it's very hard to get to work on them.
The team has identified their target. In 2010, in the northwest corner of Greenland, a vast piece of ice carved off the Petermann Glacier. Over 2 years, it's drifted south on ocean currents. 4 times, vast chunks have broken off. Now, over 1,000 kilometers from its mother glacier, the largest piece is stuck just off the coast of Canada's Baffin Island.
We were trying to make measurements where we knew most dynamic things were happening. So this is where the action
Remarkably, one of the scientists, Richard Bates, already knows this ice.
So you've stood on this piece of ice before?
That's right, yeah. Back 2009 we were up there. So before it actually broke off, we were there doing measurements on it, around it. This crack carried on around the back here, and this crack worked in its way towards it and broke that off as one chunk. And that is the iceberg that is working its way south.
For the team, there's one key mystery they want to solve. What are the physical forces slowly destroying this vast chunk of ice?
The ocean has a huge amount of energy, pushing and pulling and twisting, and I'm really interested to see how the iceberg stands up to all of those stresses.
After 36 hours at sea, looming out of the fog, an almost unimaginable wall of ice. The team has found their goal.
There it is!
I knew it was going to be big, but this is massive.
Good to be back here.
First Arctic iceberg for me. First any iceberg for me, actually.
It looks very frightening to me. It's full of cracks and fissures and cliffs and rivers. There's a huge river coming off.
And it looks entirely without life, an inhospitable lump of freezing fresh water floating in seawater.
It's just a stunning sight. I've never seen a single piece of ice that is this big. One molecule, billions and billions and billions of it in a single lump floating on the ocean. It's absolutely amazing sight.
This is the iceberg the team plan to board and explore. It is crisscrossed with crevices and melt rivers. For 2 years, it's been the largest single object floating in Arctic seas. It even has a name: the Petermann Iceberg. As soon as the team arrive, it's action stations.
Full signal on the iceberg.
We've got the funny angles that we've reset the transducers at.
First task, to scan the berg. Richard and his colleague Max want to know exactly how large it is. This equipment will reveal its dimensions, both above and below water.
Do you need it closer in, Max, or do you think this distance is a
Good offset.
To scan the berg, they'll need to circumnavigate it. And the nearer the ship is, the better the data.
Will the ping rate go up at that?
But it's a game of careful negotiation with the ship's skipper, Raggy Ellison.
15 metres towards the iceberg, if the captain's happy with that.
We are 50 meters away from the iceberg, so I'm not going to climb on board it.
Raggy is cautious, for good reason. He knows icebergs are notoriously unstable. Smaller ones can suddenly roll over, and without warning, can completely shatter. Boarding one of these smaller ones would be suicidal. Which is why the team picked the Petermann Berg. It's bigger, flatter, and they hope more stable. It's one of the remotest spots in the world. But they're not the only visitor.
There's a polar bear swimming, what, 50 metres off the ship?
Really close, and he's just hanging out. We were debating whether we'd ever see one out here. I'm actually shaking. Wow.
This is all my Christmases come at once. A polar bear. Now, I really, really, really hope to see one, but I never thought that we would. But then, you know, these are marine mammals. They can cover great distances in the sea, and they frequently do, swimming between the ice floes. Look, it's about 20 metres off now. How exciting that, honestly.
Polar bears hunt on the sea ice for most of the year. But now it's summer, the sea ice has melted, and the team's berg is the last remaining ice in the area. And it's not alone. There's another bear on the berg itself.
A polar bear on our iceberg. Hold on, Mo. Hold on. Can we have the binoculars? Can we have the binoculars, please? Turn over, Pete. Turn over. Oh, I don't believe it. I really don't. There's actually another bear over here on the ice. You can see it. Through my binoculars, there's a little speck. So in the space of just half an hour, we've seen 3 polar bears, one in the water just off the iceberg. There's one here, happy, smiling, and about 500 metres over there is a 3rd bear on our iceberg. It's bear-tastic. It's bear city.
Even experienced polar cameraman Doug Allen is excited.
Look at him, he's just lovely. Lovely, lovely bear. Don't they just look so completely at home?
I know.
You know, they totally epitomise the Arctic and ice. That's what I like about polar bears. Bears will stay on ice as long as possible. They don't like going ashore, they'll stay on ice. So, inasmuch as this is by far the biggest bit of ice for miles and miles around, perhaps it's not so surprising that they should be found here.
Despite the team's enthusiasm, these predators pose a real problem for the science mission. Highly curious, polar bears are very capable of attacking anything or anyone that enters their domain.
The intention is to go on that iceberg. But 3 bears in 15 minutes, that like adds a bit of excitement to the whole thing.
You need to change the scale to make it do.
It's much more obvious above that.
The scientists have 2 different theories about which forces are slowly breaking up the berg. The melt team believes seawater is melting it over time.
It's quite cool. So that's the main sea.
The wave team argues the ocean waves are rocking and flexing the ice, snapping it, into smaller chunks.
And that's ocean swell, which has come a huge distance.
This is Peter Wadden's theory.
Waves do have a big effect, and we need to understand that relationship between waves and icebergs as part of understanding the relationship between waves and ice in general.
Working with Peter is Till Wagner. He's the Wave team's tech head.
And this is the beautiful green antenna. It's just all green and shiny and concentric. I think it's beautiful.
To measure the size and frequency of the waves, they deploy a high-tech buoy.
Till, are you sad to see this go?
Well, I do feel quite attached to it.
It's always funny watching these instruments go out because they look so tiny. And we're just going to let this drift. We're going to have to find it again afterwards. And it looks so small out there. But it's recording exactly the data we need.
Left to ride the ocean waves, it'll beam this information back to the ship.
Here's the outside edge of it, and
Richard has completed his survey. 9/10 of the iceberg is underwater, but the scan still allows Richard to make an accurate estimate of its size. The result is extraordinary.
Okay, so we've measured the circumference. It's about 27 kilometers around here. We've measured the thickness all around, and we've got about an average of just about, say, 70, 75 meters of thickness. Gives us a volume of about 2 billion meters cubed of ice in there.
2 billion
2
meters
billion.
cubed.
Now, you could roughly say 2 billion tons of ice in there, or 2 trillion liters of water. Okay, so you've got about maybe 200 odd days of consumption for the UK.
So this water would last the UK domestic consumption for 200 days.
Something like that. If we towed it back up the Thames and, you know, tapped it into Thames water, and there you go.
That's amazing.
But the scan has also revealed a problem. Strangely, the position of the ship in relation to the iceberg seems to be constantly changing.
According to your diagram, we're in the middle of the iceberg, which can only mean one thing to me, and that is that it's moved.
Exactly.
It's complicated life for you a little bit, hasn't it?
Yes.
I'm really sorry about that.
Thank you.
It's a shock. The iceberg was chosen because the team thought it had gone aground and was stationary. Instead, it looks like it's on the move. Richard will need to deploy additional equipment onto the ice to track its shifting position. And he's not the only one with difficulties. Raggy has 30 years' experience of these waters. Even so, he is cautious about landing the team on a moving target.
You should always take the worst scenario and work out for that. Prepare for the worst.
Not often you land against an iceberg, you know. It's very exciting. There's a lot of inertia in a ship like this, so it's very easy, very quickly to do some damage.
The berg's behavior is unpredictable. It's hard to avoid collisions. And there's another unexpected problem. The team discovers a huge ledge of ice jutting out just beneath the waterline.
That's 13 from the deck.
This ice ram, as it's known, is right under the ship.
No problem, Tim. I will move. I'm moving forward. Thank you.
There's several 100,000 tons of ice down there in that van, and we're on top of it. If a crack opened and it broke off, the buoyancy would bring the whole thing up above sea level, and we'd be tipped over one way or the other. It looks like a nice, neat place to moor, but actually it's quite dangerous.
Raggy insists they search for a safer landing site.
Breaking, buddy. Are we about the right?
And as if that weren't enough, in a single day they've seen 5 more bears, 8 in total. A safety officer calls an emergency briefing.
So there are going to be a few simple rules here, which I think all of us can just get into our minds very early on. Number 1, there's nobody wandering around off the ship on their own. Number 2, you've got to make sure that there are watchers out. Number 3, you're going to need some equipment with you to make sure that you can fend off if a bear comes too close.
Having seen bears stalking seals out on ice similar to this, they're very clever. They'll see a seal from a long way away and they will take advantage of the dips and hollows to stay out of sight. Just sort of try to be super bear aware. If a bear did suddenly, you find one very close, then drop a piece of clothing on the ice.
Put a pair of dirty socks in your pocket, something nice and smelly, so you've got a couple of things to drop. It'll buy you vital seconds if you're backing off.
The Inuit have a great saying which says it's not the bear you can see that's going to get you.
It's the next morning, and Raggy has found a possible mooring spot. The bear risk calls for additional precautions.
It is a rifle.
Thank you, Captain.
Akaluk will be on guard. A native Greenlander, he's used to living with the threat of polar bears.
There should be some cartridges in there which we need to confirm with the captain.
Let's hope we don't have to use them.
It's well over a kilometre away, perhaps 1,200.
The man leading the shore party is Andy Talbot, a specialist in extreme environments. They need to secure the boat to the ice.
We're about to get the gangway across at the iceberg and take those first few steps. We'll recce sites that we can get this big ship anchors in. The point of all this is to get the scientists on there safely so we can carry on and do the science. Let's go. That's why we need crampons.
First on the iceberg.
It is.
How does it feel?
Done, mate. This is awesome. This is where the adventure properly starts.
Yeah, it is.
This is how you imagine big glacier ice.
Yeah, feel that on the top. Feel it on the top.
It's just like marble, isn't it? There's no giving that at all.
The ice looks very solid here.
Good. That's fine, go for it there.
They need ice that's hard and stable enough to attach mooring ropes. But before long, they've got company.
Yeah, well, he does seem to be moving a little bit towards the left, doesn't he?
He is, he's walking left, right?
Yeah, exactly.
Whoa, eyes on, he's just there.
Here he is.
Akaluk.
He's very close to us.
Could you give us a update, please, on situation? Still moving left to right. Okay, very good, thank you.
As long as the bear keeps its distance, the team can continue.
Beautiful. Yeah, through.
It's a good motivator for quick work.
Another couple. One more. Awesome, done. First step on the iceberg.
First person to fall over on the iceberg.
Yeah. I think, a rather unceremoniously first step for man, a giant leap for mankind. That one. Yeah.
It's taken 2 days to find the spot. just an hour to moor up. For the moment, the bears have disappeared, so the scientists can finally board. It's late, but because they're in the high Arctic, it is still light enough to work.
All right.
Till and Peter are first to deploy their kit.
This is it.
This sat ice GPS will, they hope, measure the flexing of the iceberg as it's rocked by waves.
Finally. I'm waiting for this moment. And now we've got these high-resolution set ice GPS, which tell us to a centimeter how the iceberg is moving. Beautiful.
Oh, I don't know, mate.
But one GPS isn't enough. They need to get Richard's base station deep into the interior to track how the whole iceberg is moving.
Yeah, I think we're far enough away from any immediate carving, break-in. I mean, there's still big crevasses, cracks going through here, but I think we could walk to the other side of the iceberg and we'd still find them.
But bears are known to use the cover of fog to hunt, and the weather is deteriorating.
The mist is coming in fairly rapidly. A little bit of haste would be good. Yeah. 5 minutes, less than that.
This is where it does all the magic.
Managing visibility very fast with this approaching. Okay, understood.
Once that really freezes in, we should get a nice record of what it's doing.
Okay, guys, let's go. Yeah, come on.
The following morning, the weather has cleared enough to reboard the berg. Peter and Till are desperate to get the first results from the ice itself. Could the waves make this massive chunk of ice break up?
The data's working and we're collecting data on how the iceberg is moving up and down and sideways and how it's responding to the swell.
I can see the data files. We've actually been measuring the exact movement of the berg for the last 12 hours. So this is exactly what we wanted. Got about 12 files, it's going to be about 15 seconds.
Peter's already excited by the initial readings.
Because it's a very big iceberg, it's tilting in a kind of resonant oscillation. We've seen other bergs doing that. And so by having a tilt meter on the edge, it's really going up and down.
Yeah, some more.
What's just happened there, Phil?
Okay, we just had a massive part of the iceberg just collapsed back there. But I think we're fine. Just going to disconnect this. Peter, you've got the adapter for the other, for this buoy.
In fact, this will be recording that event, probably, we hope.
But what they haven't noticed is a 200-meter fault line opening up behind them.
Is that a new crack? That is a new crack forming. That's definitely a new crack.
Just say again, I missed that last.
We can feel cracking under our feet, so it's probably, and it's falling here. Right, we should go just to go.
I've done the download now here.
Run, Peter. Run.
They have to get out of there.
We've had a major breakout down there, we had a major breakout over there. People on the ice felt cracking under their feet, so no one's taking any chances.
And for good reason. It's not just a crack. A huge block is actually beginning to separate from the main berg.
Massive crack 150 meters back. The whole thing is going. The whole thing is coming loose.
With the Neptune tied to the ice, there's a danger the ship will be dragged underwater. The detached piece will have a new center of gravity, which could easily make it roll over.
I suggest we drop the lines.
Understood, understood.
It's crazy. It's the craziest thing I've ever seen.
For most of the team, evacuating the ice is a major setback. But Peter thinks they've got the results they need.
We're very pleased to have got this equipment out because the data we have got was very luckily right from the time when an iceberg broke up underneath us, so that we now have some data that tells us what happens when a berg separates from a bigger berg, so that's great.
Peter and Till have unique data. But the other scientists are frustrated. No one knows if they'll be able to moor again. For Chris, it's an opportunity. Now's the time to study the wildlife. He wants to know how so many bears can survive on the iceberg.
It's a group of 4 seals here. They are bear burgers. They're exactly what the bears are here for. And the seals wouldn't be here unless there was seal food here. Fish, krill, other crustaceans. So this iceberg is supporting an entire ecosystem. That's very exciting. This is like a little lost world we might be able to study in some detail.
Doug and Andy are helping Chris investigate this lost world. They want to find out if the sea close to the berg is richer in life than other parts of the ocean. But their immediate concern is the animal at the very top of the food chain.
Hello, bear. He's on the move.
No way.
We're gonna have a diving buddy, mate.
Let's just see what this bear does.
So would you still dive, Andy, if you jumped in?
If he jumped in, I think that would be a bold move. We have been recorded diving to 24 metres.
Well, I wouldn't like to go in the water with him hanging around, no. It's sort of not a good sign.
What's that? What's that?
It's usually what they do when they're a little bit, you know...
Hungry?
Yeah, getting ready to do something.
Oh, look, he's looking. It's like, can I do it?
I can't believe you're going from there. He's thinking about it.
Yes,
Their sense of smell is absolutely astonishing. So they'll smell people from some way away. Maybe they heard it too. And if it was just over the back of that rise, the sound of the engines and them talking, it would have heard it. And it's just come over. Well, I say it's come over to have a look. It's just run off. But then the first time I saw Doug Allen, I looked at him and I ran off as well. So to be quite honest with you, I'm not surprised.
This close? Okay.
Doug and Andy now feel it's safe enough to go ahead.
Clear to go when you want.
Yep.
Yep, clear to go. Yep. Go in ready. Go in ready.
This place is stunning. I've never seen walls of ice in the colours of blue and white. It's absolutely beautiful. From the surface, this ice wall looks like tiny little dimples all across it. It's the whole surface. It looks like a golf ball. Can't believe how much plankton there is down here. The size of these things.
Andy's amazed at how rich the waters are around the berg.
Is that a lion's mane?
These creatures form part of a complex food chain that feeds the fish, that feed the seals, and ultimately feed the polar bears.
It's a significant peak, but it's not a great peak in the energy.
Well, you get
Back on the ship, the wave team has analysed the results of the big breakup. What do they reveal about the big breakup of the iceberg?
The red line is where we actually went onto the iceberg to download the data. And as we go on there, the berg breaks up and we see this huge jump of 60 centimeters. So the box that was sitting on the iceberg just was moved upwards, shifted upwards by 60 centimeters by the whole iceberg moving after it cracked off the main berg. That's something quite astonishing, yeah. And it's, I mean, we were really lucky to be actually on there with our sensor as the breakup happened, and that's never been achieved before.
Next, Till compares results from the wave buoy to see if ocean swell caused the cracking.
This is the day where the breakup happened, and the exact point of the breakup was where this blue square is. And what we can see from this is that there's nothing remarkable going on. The swell is really, really small. There's no peak of wave height or anything of the sort prior to the breakup. So we can pretty conclusively say that this particular breakup was not in any way caused by ocean waves or by bending due to waves.
It's official. Waves didn't cause the big breakup. In this case, the wave team has proved their own theory wrong. Now it's time for the other group of scientists to step in. The MELT team believes Arctic waters surrounding the berg are warm enough to thaw away significant amounts of ice. They're headed by Keith Nichols from the British Antarctic Survey.
In recent years, we've been seeing a lot more big tabular icebergs come off the Greenland ice sheet, and they've ended up now ending up in Baffin Bay. That's a change, and the only reason it can change is that the climate around Greenland is changing.
And Keith believes it will get more extreme.
And I think it's a warning for all of us, really, that things are changing. Things are going to look very different in 20 years' time, 50 years' time. And yeah, I think it should be a concern for everyone.
The first thing the MELT team wants to investigate is the temperature of the ice deep inside the berg. To do this, they'll need to drill into the ice, which means they'll have to get back on the berg. Raggy's not prepared to moor again. This time he'll hold position just next to the iceberg. In its own way, just as treacherous.
Sit down at about 15, take all the rope in and...
Helen joins them. It's her first time on the ice. She's been waiting for this moment for 8 days.
I've fought so many battles with the weather, with ship logistics, with fog, with polar bears, not literally. And so the fact that I'm standing here at all is honestly astonishing to me. And it makes me appreciate so much more the difficulties of studying what we're standing on. Now that we're here, the thing is to drill down into the ice and measure the temperature in the middle. And the reason that matters is that ever since this iceberg broke off the glacier, it's been gaining heat from the environment and heating up.
From measurements taken back in Greenland, the team knows the iceberg's temperature was around minus 15 degrees Celsius when it first calved.
So what we're keen to do is to find out what the temperature in the middle of the ice is, because that will help us understand how fast it's melting and why it's melting at the speed it is.
They're drilling into the very heart of the berg.
It feels like we're going to be here a long time doing this. But it is going down, the drill is going down, and we are drilling into fantastically tough material. If this was easy, the iceberg wouldn't still be here.
When the core comes out, it's still holding on to the temperature it had when it was in the ice itself. Later we can put the thermistor to the bottom of the borehole, once we've made it, and get another measurement from within the borehole, but this gives us a first good approximation to the borehole temperature.
While they drill, Chris is on bear watch.
What's that there? That's a bear.
It is a bear, isn't it?
See it? There.
Yeah.
Right, okay, it's miles away. We've got no problem. It's miles away.
But it's not just one bear.
David, we've clocked them. They seem quite close. Over.
It's a mother and her 2 cubs.
The likelihood is she'll take a look at us, if she's curious, and then lead them away. I mean, people aren't nice to bear. She doesn't want to expose her cubs, which are very valuable to her. So the likelihood of her coming close to us is pretty small.
But the bears keep approaching. At 80 meters, they're too close for comfort.
Yeah, it's coming towards us. Okay.
They've only managed to drill down 2 meters, but Keith thinks that's enough.
The group is gradually walking back to us. All personnel on board ship, we're clear of gangway.
And it's been a unique experience.
I'm not used to being interrupted by bears, actually. I mean, we come from the British Antarctic Survey, and the British Antarctic, we don't allow polar bears anywhere near us. We have the odd irate penguin, but that's about it to contend with. So.
The MEL team have their results. The iceberg is minus 6.16 degrees Celsius, 2 meters down. From this, they estimate that at its coldest point, it'll be minus 13 degrees. It's surprisingly cold. The ice is just 2 degrees warmer than when it split off the glacier 2 years earlier. But why is it still so cold? The MEL team knows the main regulator of the iceberg's temperature is the water around it. So they turn their attention to the sea. They use a device called a CTD. It measures how cold or warm the surrounding water is, as well as its saltiness.
We want to look at the ocean temperature, salinity, all around the iceberg so that we can think about whether the iceberg is melting.
Keith sees a chance to take the best measurements of all, right next to the berg. Once again, Doug and Andy help out.
Guessed at what really happens in that boundary layer between the ocean and the ice, and we simply can't get close to it because ships simply can't get in there. But when you've got divers, the divers can take the instrument right up to the wall. Very exciting to see the data we're going to get back. Auto look ready to go. Full switched on. Okay.
Straight to 30 now. All the way down.
No one has recorded sea temperature and salinity like this before.
Gonna try and keep it as close to the edge as possible. This flat edge here.
As well as taking these unique readings, Keith has given the divers another experiment. This bottle contains a tracer dye. It will reveal whether powerful currents are moving up and down the sides of the berg.
That is an
absolutely beautiful. It's like some kind of huge ruffled velvet blanket. Bizarre shape. Doesn't appear to be moving much. It's just kind of hanging there.
But the results are surprising. If there were strong currents, the dye would spread rapidly through the water. But this isn't happening.
Appears to be very little water disturbance right at the ice edge.
The dye shows the waters around the berg are still and settled. So what about the temperature of the water?
This is brilliant. Real science in action. Not a bad day in the office.
Back on the ship, Alon has his results. And a revealing insight.
As you can see here, the ocean is separated into two layers. So this is the surface and this is the bottom. We've drawn in what looks like an iceberg in the middle just to give us a bit of an orientation. And what you see is the ocean is separated into two layers. The bottom layer, which is most of the ocean, is cold and it's salty. It's like negative 1.5 degrees, which means it's actually not doing that much melting to the iceberg.
The deeper seawater here is incredibly cold, below normal freezing. This cocoons the ice underwater and explains why the heart of the berg is so cold. But the MELD team has discovered something else. The top 10 meters of the sea are very different. Here, there's a much warmer layer, which will sit on top of the cold, deeper water. And this layer is warm enough to have a major impact on the berg.
What's really melting the iceberg is the top layer, which is really, really warm. That's eroding at the iceberg, which is exactly what we've seen outside.
While they've been here, the scientists have noticed a surprising feature. A notch in the ice where it meets the sea. And now they know what makes it. The warm water on the sea surface is melting this narrow band of ice, chiseling a groove around the berg.
That's 4 or 5 meters.
Really?
It goes a long way back.
The reason this iceberg is breaking up really fast in front of us is all about what's happening at the wave cut, in the warm water layer right at the surface.
The team are realizing this seemingly insignificant notch is closely linked to the crumbling of the ice above it and the underwater ram they saw earlier. The pieces of the puzzle have come together. The warm surface water melts the notch. The ice above is unsupported and collapses. This leaves the large ice foot, or ram, which is protected from melting by deep, cold water. As this ice foot enlarges, it becomes more buoyant, and finally, the upward pressure is just too much. The ice snaps off. Only by seeing it happen in front of their eyes could the team have had this insight.
There are these enormous stresses on the ice, and the place where the damage will happen is at the weaknesses. And I thought that was a fabulous excuse to get some chocolate. This is our ice shell sticking out like this. And what we're saying is that the foot is pushing on it here. And if I push on it enough, it breaks.
It's actually creating this huge lever, which is forcing the front edge of the iceberg up and causing it to crack along the line of weakness. Now, I think we probably ought to eat your experiment.
I think that's a very important part of this experiment. Have a bit.
Thank you very much. I think that's a good few thousand tons.
The team have discovered a completely new way in which icebergs can break up. Throughout the expedition, the team has constantly faced the threat of polar bears. Although they've made life difficult, they fascinate Chris. He wants to know how many bears the berg can support. As his last job, he wants to do a census.
We've got the chopper and we're going to go out and take a look round. I'm really excited to be quite. I've waited a long time to be able to do this, so I'm hoping we'll find some bears.
So far, they've only been able to observe bears around the edge of the iceberg. But there are 40 square kilometers of ice. And by flying over the interior, Chris can get a more accurate estimate of the total number of bears.
We've got one just down here now. It's on the side of a small lake. It's a single adult bear. It's cream-coloured against the white snow, which means that we can see it. I'm just going to grab a couple of shots of it with my still camera.
The presence of these additional bears in the interior confirms the ones on the edge must be just a fraction of the population.
So, in total, looking at the circumference, which was around 27 kilometres, and how frequent we saw them, I'd go for mid-teens to 20 bears on this berg. What there is there for them is security, and I think they're taking advantage of that. So I think they're hanging out on this berg basically to stay safe and just wait for that sea ice to come back in, and then they can all charge out and hunt.
With the Arctic spring temperatures becoming warmer, there's far less sea ice. It's making it harder for polar bears to survive. It's why Chris's survey is so valuable. This is the first time a large population of polar bears has been recorded on a tabular iceberg, using it as a sanctuary. It's time to leave. Despite the hardships, the team accomplished far more in the 10 days than they dared hope.
I suppose this is it then, the end of Operation Icebergue, and what an expedition it's been. What an expedition it's been, seriously. I never thought we'd get on here, and now it's time to get off. I can't think I'll ever be on another one. It's been amazing, absolutely amazing. Just one last question now. What's going to happen to it after we left? Where's it going to end up? Where's it going to melt? Where's the last molecule of this mass of ice going to drip into that sea? Hope we find out.
And we will, because the team has left a tracking device. It will send back the location of the iceberg over the coming months, revealing its future journey. It's been a remarkable adventure. The team have seen how huge icebergs are born as they split from a glacier, and what happens to an iceberg out at sea. They'll continue to track the Petermann Berg as it floats south, out into the Atlantic. And over time, perhaps in as little as a year, the berg will disappear altogether, back into the water.